Greetings, class, and welcome to week 4 of CIS 4670. This week we're going to be looking at understanding devices and infrastructure in Chapter 3 of the Security Plus Cybex book. So this chapter is a pretty expansive chapter, primarily because it has a lot of terminology and a lot of concepts. We're still kind of doing some background information and setting the stage for what gets secured. But the premise of the chapter is to look at how we install and configure different components within a network, both hardware and software related, and how we support those platforms and programs. So, like I said, this week it's very, very terminologically impactful, for lack of a better term. I could probably think of a better term. You have a lot of terms this week, so 3 pages, 2 full pages and like a quarter page. Ensure you review them. You'll see them again, or some of them again. But we'll try to stay on topic with the higher end concepts in this chapter. And we're reinforcing this through a couple of different classes in the CIS program. We've talked about firewalls a lot. We've talked about VPNs a lot. We've talked about intrusion detection systems, intrusion prevention systems. These technological concepts are very important for a multitude of reasons. One, the environment that you go and work in when you get a job out in the workforce, in cybersecurity, in information technology, you're going to have to be used to working with these platforms. Next, if you go and take that next step after your bachelor's degree, and you look at getting certifications, whether it's the Security Plus, the CEH, the CISSP, or a SANS certification, what have you, guess what? The concept is transportable from certification to certification to certification. The definition of an IDS, the definition of a VPN, the definition of a firewall is the same under CISSP as it is under CEH, as it is under XYZ. Okay? I like to tell this to students a lot. If you study for one certification exam, you're basically studying for multiple certification exams. When I got my CISSP, I knew about 80% of what was there for the CISA, what was there for the CEH, etc. Because a lot of these theory-based certifications, they pull from the same knowledge base. Okay, so designing with security in mind, we're going to look at firewalls, VPNs and VPN concentrators, and I'm going to get to that in a second, and the intrusion detection, intrusion prevention systems. So with firewalls, we're basically looking at those devices that block traffic. They should block traffic by default. There are different types of firewalls that we will look at, whether they're packet filtering or URL filtering or proxies. We'll get that in just a second. Then we have VPNs and VPN concentrators. The difference there is basically a VPN is a virtual private network that is set up between 2 devices that encrypts the traffic and authenticates the user. A VPN concentrator is a piece of hardware. A VPN concentrator is the device that you are terminating the VPN on. I could go a step further and say that a VPN appliance is a device that has VPN functionality in it. You see that in a lot of next generation firewalls or security appliances. And a VPN concentrator would be a device that is completely dedicated for VPNs only. And intrusion detection systems, we'll touch base on that here in a minute. So the different firewall types, and this starts out on, I think, page 84, 85, through 87 of your text. The different firewall types, and I'll let you read about them in a little bit more detail. This kind of is the precursor to today's next generation firewalls. They have, of course, packet filtering capability. They have stateful capability. They are able to proxy traffic. They are able to do all these first, second, third generation firewall duties. The firewalls today, the next generation firewalls, or the deep packet inspection firewalls, they look inside the packet payload for anomalies. All right, and then we have the Unified Threat Management, UTM, specialized security appliances. And basically what we're looking at with UTM is where we have advanced features within the device that gives us more granularity with what we are inspecting. So we can look at URLs. We can compare a URL with a blacklist of known websites that are sketchy, deny traffic based on that. Content inspection, which will go into the packet and look at content that is in there. Malware inspection, where we look at signatures both from a packet perspective, a packet header perspective, and a deep packet inspection perspective, looking for malware, looking for signs of malware. Web application firewalls that look at different types of signatures that come from, say, known hacking tools, OWASP scanners, Metasploit packages that target specific web applications, things that might look for cross-site scripting or SQL injection. And then we have application-aware devices, and these are built into the device itself and looks at policy-based information from a standpoint of, is the user who's requesting something from me legitimate? Are they able to do what they are requesting? So going back to VPNs, it's important to kind of note what a VPN is. And from that perspective, a virtual private network is a channel that is set up between two devices, whether it's a laptop, mobile device, PC, and a network. And that lands you on the network that is secure, and that tunnel that goes between your device and the network proper is encrypted and authenticated. There are different ways that we can set these VPNs up. We can set them up within appliances, which is most common these days, or you see this in specific organizations. We may have a firewall or firewall device or appliance device that is set up as a VPN concentrator, and that is basically that device's only job is to act as a VPN management platform. Okay, so what goes into a VPN? Well, there's several ways that we can set up a VPN. First off, the forerunner of encrypted VPNs was GRE, which stands for Generic Routing Encapsulation. And GRE can leverage things such as IPsec and authentication mechanisms, or it can just tunnel traffic in the clear. After that came IPsec, and IP security is a whole host of features and protocols that build a tunnel. And it is still kind of considered some of the most secure VPN setups that we have. Transport layer security works with web traffic. This used to be SSL, but now TLS has taken over for SSL, and we can set that up with browser-based VPNs. And finally, there are different types of characteristics of VPNs. Split tunneling is the concept of where we are able to use our own internet connection instead of using the internet connection of the VPN that we are terminating on. Or we can split off access based on user profile through authentication and authorization as to what you can get to when connected to the VPN. That's a better definition of split tunneling. And finally, we have always on VPNs, which is basically manufacturers today can script into your device that your VPN turns on and you're connected to your VPN and it's always on and you're always using it. You see this in more commercial type of VPN products such as NordVPN, where when you turn your computer on, you turn your device on, boom, it automatically connects you to the VPN and you're always using it. So with intrusion detection systems, this is a big review from 467 primarily, and we talked about it last week a little bit here in 4710. Intrusion detection systems look for malicious traffic, and they base it off of policy and they base it off of signatures. Okay, so in rough description, an IDS is going to be software that is running on hardware. The hardware could be dedicated. That is going to monitor and track network activity. When it finds something that is suspicious, it will give you options as to what to do. We'll get to that in a minute. Intrusion detection is also the process of monitoring events from a system or network aspect and helps us determine if an intrusion is occurring. Present tense, not past tense, present tense. An intrusion is basically going to be defined as any activity or action that attempts to compromise, infiltrate, breach integrity and confidentiality, or subject the system to loss of availability. So, why do we use an IDS? This is a good test question. Are the four primary uses for IDS? Behavior-based detection, so we look at anomalies. Signature-based detection, which is also commonly known as a misuse detection. That's your traditional IDS. Anomaly detection and heuristic intrusion detection. The latter two are used more in intrusion prevention systems, so that we can identify occurrences of an intrusion or a breach that may not otherwise be known through a signature. IDS IPS comes in two flavors, network and host-based. A network-based IDS is going to have some sort of monitor on a segment, and it's going to go to your IDS monitoring system. It will record those events, throw them into a database, throw that to a NOC so it can be monitored, and we also have a historical record through logging. You can do this through a couple different ways. They use the example of using a hub, which is one of the reasons that you can use a hub these days. However, hubs are very slow. They allow for collisions. They can be a point of congestion on a network. But typically what we do instead is we set up a span port or a mirror port, depending on which manufacturer you're using, which terminology, and that dumps data, typically on a port level or VPN level to the management software. So there's passive response and there's active response in the intrusion prevention, intrusion detection system. Passive response is the most common. Basically here we're saying that, okay, a signature has been flagged. We now have a reason to record something, and that is typically logging or some sort of SMS notification. The other type of active response, and I kind of goofed this up, I apologize, is shunning. Shunning is where we basically do like a TCP reset, or we might have a dynamic ACL that's written in real time. All right. Other active response could be our take on the characteristic of resetting that TCP session, writing the source IP into an ACL, terminating the process, resetting the process on the host, or in some mechanism way to ensure that a breach does not occur. A host-based IDS/IPS is basically going to be sitting on a server or workstation or device, and it is going to be looking for these signatures as they come into the end device itself. Typically calling itself a HIDS, H-I-D-S. It's designed to run on an endpoint system. They're very popular, again, on servers and workstations. You can buy them off the counter as well. So, know the difference between an IDS and IPS. A IDS is typically reactive, where an IPS is proactive. IDS is typically passive, where IPS is active. That's the big difference. Also, IDS uses sensors and relies heavily on signatures, whereas an IPS is in line or within a device in and of itself, like a firewall appliance. So, how do we respond to this? Logging, notification, shunning, which are active, which are passive. That's going to be a big part of the test. All right, and then as we wrap this lecture up here today, we're going to look at how we protect networks. So intrusion prevention systems, intrusion detection systems focus on prevention. And these systems focus on signature matches that take an action or a piece of action, and then based on how severe it is, do a reactive action, such as killing a TCP session, resetting a service, writing an ACL, etc. All right, so at the latter part of your chapter here this week, we have a lot of terminology with end devices. And these are all mostly end devices, but you need to understand the definition of each one and where they're used, and also what layer of the OSI model they land on. So a router basically routes packets, right? A switch switches Ethernet frames. A proxy sets as a traffic cop for outbound connection. A load balancer sets up balancing for inbound connections to typically web farms. An access point allows wireless connectivity. Security incident and event management platforms, which we'll get into a little bit more detail later on in the course, look at housing or collecting log data and then parsing through it and analyzing it based on information it gets from multiple areas. DLP, or data loss prevention, looks at transactions, TCP connections, UDP connections, transfers, and looks at specific strings within the data and flags it. What is it looking for? It's typically looking for social security numbers, PII, identifiable data, something that's going to throw a red flag and go, okay, why is this leaving the network? Not that it's coming in, that it's leaving the network. Network access control basically helps us break down who has access to what devices and why. Mail gateways, or SMTP gateways, control the flow of mail. A bridge, which you really don't see a whole lot anymore, except maybe within access points, can be used to bridge two broadcast domains together. SSL TLS accelerators help out with the ability, hold on just a second. Oh, I remember now. I was getting the SSL decryptor was throwing me off. SSL accelerators basically speed up the encryption process on SSL, VPN, TLS devices. SSL decryptors. This is kind of cool. This is where you can take SSL keys, SSL certs, and proxy them on a firewall appliance, and then you can see inside encrypted traffic that is originating from your network. It's actually kind of really neat. And last but not least, media gateways is one of the newer appliances where we're basically looking at web security gateways, which can be thought of, again, as a proxy server, or they perform proxy functionalities with web protection software integrated into them. Okay, so in brief, what you're going to need to know for the exam, which is going to come up here in a few weeks, is describe those various components. Always look at the very beginning of the chapter for all the terms. Know the difference between IDS and IPS. Know the different load balancing types, the different VPN types, and the difference between IPsec GRE and TLS VPNs. So that is kind of it for this week. Good lecture. We'll also be looking at, you know what, let's just take a quick look-see here at, let's just take a quick look at the syllabus so we don't forget anything for this week. We are in week 4, devices and infrastructure. Homework 2. Homework 2 is due. Let's take just a quick look-see at that. Oh, yeah, so we went over this in class this past week. So you're just looking at getting and obtaining a free antivirus utility, installing it on a system, taking some screenshots after you have ran a scan, and show that you have actually locked down your device. So it doesn't have to be a free antivirus utility. If you have something already built in, other than like Windows Defender, that's fine too. But there are plenty of free antiviruses for all different types of platforms, Windows, Linux, and Mac. The two that seem to be the most popular these days are AVG and Malwarebytes. So after that, when you're done doing that, installing, giving that screenshot, provide the results, do a 1 to 2 paragraph as to why you chose that particular program. There's no wrong answer on this. I just kind of want to see that you actually went through the process and thought out, okay, I want to get this program because of this. Whatever this is, that's fine. I just want to see what your thought process was. So with that, I'm going to bid you a farewell and wish you a great week 4. I will try to get grading caught up as best I can, especially during my office hours this week. I will be in office hours this week, so we'll see you around there as well. So have a great week, everybody. This is Dr. Brown signing off.